So first of all, we're going to give you a little bit of overview over Google Apps and the APIs very quickly, and then dive into the Google Data Protocol and talk about the future of our Google Apps APIs. Then we'll talk specifically about some of the recently launched APIs, including ones that were launched just a couple days ago and ones that were launched last week. And lastly, end up talking about distribution opportunities quite quickly as well. So how many of you use Google Apps? Okay, fair numbers, but not all of you. So Google Apps is our suite of communication and collaboration tools. Things like Gmail, Calendar, Documents, Contacts, etc. And we have 40 million active users of these applications at 4 million businesses with 5,000 new businesses signing up every day. But these customers need more than just the applications that Google offers in order to achieve the vision of 100% web for business. And this vision is all about making sure that customers run their business as efficiently as possible. The customers don't have to deal with the normal IT hassles and costs of maintaining and updating their software. That they can experience the latest innovation by just hitting the refresh button in the web browser. But like I said, our customers need more than just Google applications. They also need applications that are built by you. Applications which are integrated with Calendar and Contacts and Docs, integrated with the customer's data to eliminate data silos and make the customers more efficient. These are things like CRMs or project management tools that you can sell to our customers via the apps marketplace and reach those 40 million users. In addition to these applications that you build and sell to our customers, you also have applications that you can build custom. You can build custom applications on top of Google technologies or other technologies and accomplish things like integrating with specific customers' finance systems or HR systems or other things that our customers need. And each of these types of applications, the Google applications, these third-party applications that you build and sell to our customers, as well as the custom integrations that you build, all sit on top of the same cloud management platform, which provides a single identity and a single sign-on solution for every user. We offer a variety of different types of APIs. We offer application APIs that allow you to connect users with their data in things like Calendar or Contacts or Docs. But we also offer domain management APIs. And these domain management APIs allow you to administer users' Google Apps domains to either help them migrate or manage them day to day. In addition to the data APIs, we also have hosting APIs with Google Apps. We have things like App Engine, which many of you are already aware of, and then we also have AppScript, which is our automation engine in the cloud, which allows you to write server-side JavaScript, which integrates with Google Apps APIs and third-party APIs. And lastly, we have UI extensions. Calendar, Site, and Gmail gadgets, which allow you to run your application inside Google's UI. And we're also going to be talking about some UI applications which allow you to run some Google code on your site as well later in the presentation. But a good chunk of this presentation is going to talk about building the next generation version of Google Apps APIs, and in particular those data APIs that we talked about. Most Google Apps APIs to date are built on top of the Google Data Protocol. The Google Data Protocol has been around for about 5 years now, and the Google Data Protocol basically defines a fairly heavyweight stack. The stack is HTTP and HTTPS for transport, client login, auth, OAuth 1, and OAuth 2 for authorization. This is both our proprietary client login and auth mechanisms as well as the standard-based versions on OAuth. The stack also defines XML as the data format with Atom syndication, Atom publishing protocol, and special Google Data API features all on top of that. Again, a fairly hefty stack. In addition to a hefty stack of protocols to deal with Google Data APIs, there's also a heavy data format over the wire. The heavy data format looks something like this. This is really tiny, I realize. Actually, it's pretty big on the screen behind me. But overall, pretty tiny. And this is an example feed from the Google Calendar Data API and it shows you retrieving a list of events in a Google Calendar. But we haven't even seen a calendar yet. We haven't even seen a single event. This is just all metadata. This is metadata that is part of the Atom specification of the Atom Publishing Protocol or the Google Data API. All metadata, which provides a very hefty weight experience for developers. And as developers especially move more towards mobile platforms, they need lighter weight protocols in order to work on limited bandwidth. The Google Data APIs currently also have a little bit of feature inconsistency. So Calendar API has partial foot and partial update. The Docs API has batch support. And a variety of other Google Apps APIs have different protocol level features. So we have some challenges for developers. First of all, with Google Data APIs, we require knowledge or expertise in adjunct specification, whether it be Atom Publishing Protocol, or OpenSearch, or XML, or XML with namespaces. We require all sorts of knowledge about these different adjunct specifications. We also have this very verbose data representation, which you just saw. XML is not easy on some platforms, especially with the namespaces that I referred to. It can be very difficult to work with XML on some platforms. Because of the way that our feeds were structured as XML with Google Data APIs, we had a hard time maintaining client libraries, or we have a hard time maintaining client libraries. We basically take every single XML element and translate that into a native class in each of our client libraries. And that's all done manually. So as we release new APIs or new features, our developers that are using our client libraries sometimes don't get to actually use those new APIs and new features. And we consider this unfortunate. And then lastly, we have the inconsistent feature sets, which you saw, so the developer is used to using partial update and partial retrieval, and then goes to a different API, they may not be able to use that feature. So this is why we built a new API stack, to solve some of these problems. At Google, we always like to iterate and launch new versions of things to improve the developer experience for you guys. So this new API stack is much easier. Built on a single protocol for transport. We require all of our API calls with this new stack to be done with HTTPS. It's also built on just the standard authorization mechanisms. There's no more proprietary client login awesome with these APIs. We also have JSON as the primary data format, as a read-write data format. So as a developer though, you really just need to deal with HTTPS, OAuth 2, and JSON. That's it. How many people like JSON more than XML? All right, so that's nearly every one of you. Let's do the inverse. How many people like XML more than JSON? Is there anyone? Anyone? Oh, there's one. All right. Hopefully that guy isn't hated by the rest of you, but there's at least one person that likes XML more than JSON. But pretty much everyone else really likes JSON as a data format. So I'm excited that all of our new APIs are based off of that as the default format. Now the available APIs. If you've worked with a variety of Google technologies, you've noticed a number of APIs launching on this new stack. The Google Plus API, the Prediction API, the URL Shortener API, etc. But we just recently started launching Google Apps APIs based off of this new infrastructure. We have Calendar v3. And Calendar v3 was launched just this Thursday, just 2 days ago. We also have the Group Settings API, which was just launched last week. And then the Task API, which has been around since Google I/O. And others we will migrate to this new platform eventually. So let's talk about the features of this new platform. Beyond consistency, let's talk about some of the features. First of all, a simpler data format. The JSON data format is default for read and write. With Google Data APIs, you can use them. We did have JSON available as a read-only format, but it was really ugly. It was JSON, but it was translatable back and forth between XML. So we had namespaces in JSON. Imagine how ugly that is. So the new JSON data format is easy to construct, easy to parse, and easy to comprehend. We'll see some examples. The improved consistency allows us to update the API infrastructure to add new protocol level features like partial get and update for all APIs at once. The previous way we developed Google Data APIs, you would add a partial fetch and update, and then every single API would need to implement that, or at least release a new version based off of our central libraries, and that led to that inconsistency. So with the new APIs, we don't have that. We can have consistent features across each of our APIs. So let's talk about partial response here a second. So how many of you build mobile applications? A lot of you. With the previous Google Data APIs, we really stuck to REST, or representational state transfer. Basically, anytime you needed to update a single entity, like say a calendar event, you would need to retrieve the entire calendar event and update what you wanted to update, and then put it all back. So if you wanted to update just a single character, you're having loads and loads of data going over the wire. This is inefficient. With partial response, we actually allow you to get just the data you need. So for example, with Google Tasks, if you created a mobile application which displayed a list of the user's Google Tasks, and that's it, all you would need to do is request the names of the Google Tasks, the titles of them, as well as the IDs. And you can do that by just passing a really simple query parameter in the request called fields, and saying, I want the items with IDs and titles. Very easy. And then when you go to update this, all you have to do is pass the single field that you want to update. This is what partial update is all about. So if you wanted to update just the title of a calendar event, or just the notes in a task, as in this example, you just have to send that information. You do this by doing an HTTP patch and passing in just the JSON object that you want to update. Also, like I mentioned, the Google Data APIs really stuck to REST, but there's many types of API operations that you want to do that are much better served by an RPC type call rather than a REST API call. So imagine, for instance, if you have a picture and you want to rotate that picture because the picture was taken upside down. If you did that with REST, you have to retrieve the entire picture, rotate it on your computer, and post it back up or put it back up. And this is obviously inefficient. Well, these types of RPC-like calls are also better for working for some Google Apps APIs as well. So here's an example with the new Google Calendar API, the V3 Calendar API. And we are, in this case, moving an event to be owned by, instead of it being owned by John, we're moving it to be owned by Tom. We're changing the owner of the event. And all we're doing here is saying, we want to move this event, here's the event ID, and here's the destination calendar. Very simple. Now I talked about our client libraries, and I talked about how it's difficult for us to maintain our client libraries because we are manually hard-coding each of these classes for each of these APIs, for each of the languages which we support. Well, we now have a discovery protocol, a dynamic discovery protocol, which basically returns, is it just another API? And this API returns the list of URLs, verbs, and parameters, as well as the schema and data format for each of our APIs. This allows us to build dynamic, or generic, however you want to call it, client libraries. These client libraries actually are based off of a single generic client library that works with all of our new services on this new infrastructure. And this single client library can retrieve information about the APIs and be built dynamically. So for like Java and .NET, strongly typed languages, we actually build the classes in advance, but we're using this discovery protocol in order to build them. And then for scripting languages like PHP, Ruby, or Python, we just use built-in language constructs such as associative arrays or hashes in PHP in order to store the data coming back. It makes it a lot easier for many of our developers to integrate with our services and, like I said, take advantage of the latest features. In addition to building the client libraries based off of this discovery protocol, we also build this APIs Explorer. How many people have already used this APIs Explorer? Okay, just a couple of you. All right. Well, definitely check this out. This APIs Explorer works not just for Google Apps APIs, but all sorts of APIs at Google. I'm going to click it and open it here. And basically here, at the top left, cut off here. So let's escape out of here. Okay, so the APIs Explorer lists each of the services that are APIs, or services that we offer as APIs. So we can see here we have Blogger and Calendar and other things. And I'm going to go down here to Google Tasks. We click on Google Tasks, and then we list each of the versions of the APIs, and then we list each of the methods that are possible. So I want to say return all of the authenticated users task lists. And I'm going to hit execute here. And we're going to notice this error at the bottom says that this method requires you to be authenticated. You need to switch to private access. So I'm going to step up here and say switch to private access. And since I've already authorized this API with OAuth, I immediately get back. Sorry, I've already authorized this API and the APIs Explorer with OAuth. I immediately get access. So then I hit execute again. And now at the bottom here, we scroll through, basically we get back our list of Google Tasks. And I only have one list, the default list. And there's the ID, and I just copied that into my copy buffer. And I'll go back here and say I want to list all the tasks that are in that task list. So I'm going to choose here, and I'm going to paste in that buffer and say execute. And then we can see at the bottom here, zoom out a little bit, make sure you can see that. At the bottom here, we list each of the tasks that are in this task list. So we have the talk that I gave earlier today that I marked completed, and then we have the talk that I'm talking with you about right now, which is list there. And you can explore each of our APIs like this, and not only do read-only operations, but also do write operations. So let's switch back to the presentation here. And that was the APIs Explorer. But what if you want to, say, register a project with Google and get access to these APIs? That's what you use the APIs console for. You can register, you can accept the terms of service, you can get OAuth credentials, and you can also manage your access to these APIs and see how many requests you're performing, and see where you are with respect to the quotas that exist, as well as see any errors that your API calls are returning. Very helpful. Let's talk about some of the specific APIs. The first API that I mentioned that we launched on this new infrastructure is Google Tasks. This was launched back in May at I/O. This was one of our most requested APIs. Many developers were looking for ways to integrate with Google Tasks. It exposes much of the functionality of the task manager. How many people use Google Tasks on a regular basis? Actually more than some other things. Okay. I should use Google Tasks more. I often use it for about a week at a time and then stop using it. That's kind of bad, but I should use it more. Google Tasks is this interface that sits at the bottom of Gmail. And you can see it here. We have a list of tasks, and then we have the individual tasks. And those are represented in JSON as well. We have the list of tasks that are available at task/v1/user/me/list. And then we have all the tasks that are on a given list. A task/v1/list/the list ID, and then the task. And it's all this quite simple JSON. When we talk about building Google Calendar, it's basically, this is one of our most used Google Data APIs, and we really wanted to move it to the new infrastructure. This API actually launched in 2006, the same year as I started at Google, and this was the first API I worked on at Google, so this sort of has a special place in my heart, and I'm so excited that we actually launched this new API, the new version of the API on the new infrastructure this past Thursday. Exposes much of the functionality of the Google Calendar UI. I bet you most of you are familiar with this. And a very simple data model. You have the list of calendars, and you have the list of events. Now, the new Calendar API does allow you to do a lot more beyond just your list of calendars and events. You can manipulate ACLs and set custom properties and a wide variety of other features. But for most developers, all you really need are these two endpoints. We've also, with this new API, launched some additional features beyond what the previous version, V2 of the API, offered. We allow you to manipulate the colors on individual events. So you can generate a picker based off of the available colors and allow users to select what colors their event should be and then set them on individual events, as well as calendars. And most importantly, there's better recurring event handling. So many developers had problems with dealing with recurring events in Google Calendar. The previous calendar APIs used purely the iCal syntax for dealing with recurring events. This is a very complex RFC that developers had difficulties constructing this iCal syntax and just kind of posting it in their XML. With the new API, we do support the iCal syntax when you're creating recurring events, and the iCal syntax allows you to specify repeat this event on Thursday every week, for instance. But oftentimes you want to get a list of each of these instances, and the new API allows you to do that. You can say, this event that repeats every Thursday, give me a list of all occurrences. You can also create an exception. So for instance, if your event is your team meeting and it repeats every Thursday, but one week you decide to move it to Friday, you can create an exception that says, this particular instance should actually be on Friday this week because someone's out of the office. And lastly, it allows you to reset these instances. If you create this exception to the recurring event, you can then reset that exception. This is actually another one of those RPC calls examples. This works a lot better as an RPC call than as a REST API call. And the last feature that I want to talk to you about in the new calendar API is the default reminder manipulation. A lot of developers wanted this. Developers were able to manipulate the calendar reminders, so like SMS, pop-up, or email reminders. They were able to manipulate that on individual events, but they weren't able to manipulate that on calendars that they created. And this is very useful, especially if you're trying to synchronize with desktop calendar systems. So the group settings API is another API that we launched recently, again, based off of this new infrastructure with JSON as the default data format and a more consistent protocol set. The group settings API offers you the ability to manage settings under groups. This may sound a little boring to you, but it is an administrative API that we've received numerous requests for, especially for those of people who are trying to migrate to Google Apps. To give you an example of how we use Google Groups at Google, we use them as email distribution lists. Pretty much every team at Google has 1, 2, 3, or 4 email distribution lists for their product. The engineering team, the product management team, the developer relations team, etc. We also use them in access control lists. So for instance, if you're sharing a Google Doc, you can share it to a group instead of to individual users. If you want to share it to an entire team of people, you can share it just to a group alias. And you can also use this with some of our APIs, like the Google Storage API. Now, Google Groups can be created using the UI and the provisioning API. But oftentimes we want to really manage the settings programmatically. Another example of how I use this, we manage trusted tester programs in developer relations, have developers try out the next versions of our products. And these trusted tester programs are often managed with mailing lists. But there's a lot of settings that we need to configure on these mailing lists, whether we want to allow posts from external users or not, posts from individual, from just users that are on the list or posts from anyone. Things like that. And oftentimes when creating these, we'd be copying and pasting from the UI. We'd open up 2 windows and say, this setting needs to be over here, this setting needs to be over here, very painful. Well, the group settings API allows you to automate all of this. It's launched just last week. It's the first of our new style APIs in the management space, and it's very simple operations. Here you can see some examples of those operations. Basically getting the settings and setting the settings. It's very simple name-value pairs, but powerful for many businesses that integrate with Google Apps. So now we've talked about all of our data APIs, all the new advances in our data APIs. The data APIs are what allow you as an application developer to connect users with their data and allow you to manage the Google Apps settings. Now I want to talk about AppScript. How many of you have used AppScript? Okay, how many of you have heard of AppScript? A few more hands. AppScript is our automation engine in the cloud. So if you think about the functions that you do regularly in Google Apps, and the functions that are repetitive for you. So for instance, if you send emails to 30 of your customers at once, or you want to create a bunch of different Google Docs or Google Sites, or you want to do a bunch of changes onto all your contacts at once. These are functions that right now you have to do manually in the UI, and it's very, very repetitive and annoying for users. And we like to say that AppScript allows you to not hate your life, but instead automate your life by writing JavaScript that runs in the cloud on Google servers. Now don't mistake this for JavaScript that runs in a client. You can't manipulate the DOM or anything like that. This is JavaScript that runs on Google servers. AppScript is just another programming environment. Just like all of our client libraries enable you to access these new APIs with the latest version of the client library and your preferred programming language, AppScript allows you to access these new APIs as well. AppScript has this built-in feature, which you can access from the file menu in the AppScript editor, that allows you to integrate with these different Google APIs, and it uses the discovery service of this new API infrastructure in order to learn about the features of these APIs. So right now you can integrate with BigQuery, prediction, tasks, and the URL shortener fairly easily using AppScript. So there's a number of new features in AppScript, and we're going to briefly talk about them, and then we're going to get some live coding. So AppScript has this new feature for caching, using memcache, locking, has a UI builder for you to build custom user interfaces that sit inside Google spreadsheets or run as a standalone web application. Underneath this actually uses GWT, for those of you familiar with it. And then we have charting. We have Gmail, allows you to read and write Gmail from within AppScript. And then we have Google Docs. Let's switch over to a live coding example here, though. I'm going to try to size my window such that it fits in. Maybe. Okay. Now what we're going to do here is send a greeting to all of you. And we're going to send this greeting in a Google Doc. So I'm going to create a Google Doc. Good afternoon, GDD is what I'm going to call the Google Doc. And this Google Doc is where I'm going to print out some messages from a script. But I'm going to write the message in English, and I'm going to have the script translated into multiple languages, and we'll see how this works here. So I have this doc, and I'm going to go over here, and AppScripts right now reside in a spreadsheet or in a Google site. So we have to create a spreadsheet here, and we'll call it Good Afternoon GDD. And in that spreadsheet, we're going to go up to the Tools menu and say Script Editor. And again, unfortunately, we'll name this again, Good Afternoon GDD. A lot of naming, but once you get done with this, you can automate everything else. All right, so we have my script. And now what I want to do is print out an English phrase. So to start off this, I'm going to print it out in English. So I'm going to say English phrase. Okay, everyone see that in the back too? Screen if you can't see it. Okay, I can't hear the screen, so this is good. So we're going to print out this English phrase, and this English phrase is going to say, Good afternoon, developers. And we'll say machine translation isn't always perfect. It's better in the Romance languages, but when we got to Hebrew and Tel Aviv, it didn't work out so well. But we're saying, good afternoon, developers, machine translation isn't always perfect, and we want to print this out to the document. So what we're going to do is include the doc ID. That's not the doc ID. The doc ID is available up here. Slightly cheating, because you can actually get a list of all your docs and select it based off the title and things like that. But we're going to take this doc ID, and then we're going to open up a doc by that doc ID. So we're going to say document app.open by ID. And you can see this is all a web-based IDE. You're writing JavaScript code in a web-based IDE, and this code is running on Google servers. We're going to pass in the doc ID. And now we're going to open up we open up the doc. Now we're going to write to the doc. So we're going to say doc.append paragraph. and we're going to pass in the English phrase. All right, so now when we append the paragraph to the doc, it doesn't immediately clear the buffer and save the doc. So we're going to say doc.save and close to do that. And we'll save this here. Now we're going to hit the run button, and it's going to prompt me for access to my Google Docs, so I'm going to authorize that. So now I can run the script. And now I'm going to hit play here, and I'm going to jump over to this document, and you can see it wrote, "Good afternoon, developers. Machine translation isn't always perfect." So one step of the way there. Now the next thing, though, I want to do is define a set of languages that I want to translate this into, this phrase into. So I'm going to say languages. And we're going to translate into German, of course. We're going to also translate it into Hebrew. We'll say some Arabic, some Japanese, some French. Any other languages? Hungarian. All right, Hungarian is what I heard. Does anyone know the two-letter code for Hungarian? HU? All right, so we're translating into Hungarian as well. And now we're going to loop through these different languages using a standard for in loop. So for var x in languages. And so the language that we're going to translate to is languages at x. And now we're going to get the translated phrase. So we'll say translated phrase equals language app dot translate. And we pass in the text, which was English phrase. We pass in the source language, which is English. And then we pass in the target language, which is language 2. So there's a translated phrase. And again, we need to open up this doc, and we need to append the paragraph. We're going to create a method to abstract this a little bit, but we append the paragraph with the translated phrase, and then we say doc.save and close. But I don't want this all to output right away. I want to have a little bit of lag in between the output, so I'm going to go and say utilities.sleep. And we'll sleep for 2,000 milliseconds or 2 seconds. I'll go over to the document here and you'll see me clear out this text. And now we'll go over here and run. Step back and look at the doc. It's printing out the English phrase, and it's waiting 2 seconds. How bad is that German? It's okay. Well, I said machine translation isn't always perfect. And so we're printing out, so then we have Hebrew, and we have Arabic and Japanese, some French, and some Hungarian. Now, how bad is the Hungarian? It's good? Oh, wow, nice. All right, so that was our live coding exercise. We took in an English phrase, we opened up a Google Doc, we appended paragraph by paragraph to that Google Doc, an automatic machine translated version of that English phrase. Hope everyone liked that. So the last API here that I want to talk about is our Picker API. Now the Picker API may seem a little disjointed from these other APIs, but it really goes on the theme of offering this series of APIs that allow you to build deep integrations with Google Apps. Now, I work on the Google Apps Marketplace and with hundreds of partners who are building integrations with Google Apps. And many of the partners build an integration like this. This is from ManyMoon, the project management app. And in ManyMoon, you can attach a Google Doc to a project in the project management app. But ManyMoon has to produce this list of all the different Google Docs that are in your account in order to allow you to select one and attach it to your project. Not only does ManyMoon have to build this, but hundreds of other developers at different companies who are integrating with Google Apps and launching on the marketplace are all building these Doc Picker UIs. Well, this is inefficient. We want to make life easier for you as developers. In order to make life easier for you as a developer, we built the Picker API. The Picker